Hi guys, it's Mrs. Lassie. My video is super tiny because I made the screen larger. It seems like if I try to do it in presentation mode, it won't record. So I'm trying to make the part you see as big as possible. So hopefully you can hear my voice. So today we're going to be using exponents to calculate volumes and the area, so you can see how that goes. Okay, so the goals of today: I know how to evaluate an expression that both have an exponent and addition or subtraction, and I know how to evaluate expressions that have both an exponent and multiplication or division. So in 14.1, this is the first page of your text. You should be seeing the blue square and the green cube. It says, based on the given information, what other measurements of the square or cube could we find? So you might say we can find the area of the blue square, or the area of the square is 9 square units. Or you could do the perimeter of the square, which is 12 units. We can find the volume of the cube. The volume of the cube is 27 cubic units. So 3 times 3 times 3. And the surface area is 54 square units. So that is on a chart that looks like this. So if you're doing the area of the square, the answer was 9, you can also show that as 3 squared. If you're showing the volume of the cube, which is 27, that could be 3 to the third power, or 3 cubed. And the surface area of the cube, 54, could be shown as 6 times 3 squared. Okay, so moving on to 14.2, calculating surface area. So here we have, on the left you have Jada's method, and on the right you have Noah's. So if the cube has a side length of 10 inches, Jada says the surface area of the cube is 600 inches squared. Noah says the surface area of the cube is 3,600 inches squared. Here's how each of them reasons. So they both start out with 6 times 10 squared. But on Jada's method, she says 10 squared is 100. I'm going to multiply that by 6, it's just 600. In Noah's method, he said I'm going to do 6 times 10 is 60, and 60 squared is 3,600. So which method do you agree with? I hope you said you agree with Jada, because you know, and we've been talking about order of operations since the beginning of school. So you have to do the exponents first. Parentheses, exponents, then multiply and divide, then add and subtract. Okay, so a good way to solve problems is to read it 3 times. So what are they asking you? The second time you read it, what is countable or measurable? And third time, how am I going to start this task? So in 14.3, you can turn to that page. You have 2 columns of problems, and you don't have a partner, so you're going to show your work on all of those. So pause the video, do the problems, and then come back in a minute. Okay, so hopefully you've just solved those problems. We've done this enough times where you know that a lot of times when we do this, the columns match, right? So 5 squared is 25, plus 4 is 29, and then the second column, it's 2 squared is 4, plus 25 is 29. So all the answers in both columns should match. So we just really want to remember to focus on exponents going first, and then your multiplying and division are equal, and then after that you will be adding and subtracting. All right, so let's go to the are you ready for more problem. So consider the equation something squared plus something squared plus something squared. An example of three whole numbers that could go in the boxes are 3, 4, and 5. So since 3 squared plus 4 squared equals 5 squared, which would be 9 plus 16 equals 25, can you find a different set of three different whole numbers that make this equation true? How many sets of three different whole numbers can you find? And then try doing it using cubes and then to the fourth power. Okay, and then if you're interested, you can research Fermat's last theorem. See what it says. All right, so the cool down will be in Google Classroom, and you're to do the practice problems for lesson 14. And then tomorrow I will post the answers for lesson 14. All right, I hope you guys are doing well. I really miss you already, and I hope you're keeping up on your studies so that when we get back, we can just pick up where we left off. All right, talk to you guys soon.